Morning students, chapter 5 laws of motion. In the last lecture we have discussed about law of inertia and Newton's first law of motion. Until an external force is applied, stationary object will remain in stationary condition and object moving will continue its motion with uniform velocity. So yes, it means force is zero, acceleration is zero. Force is non-zero, acceleration is also non-zero. Okay, now we will see Newton's second law of motion. But before that, we have to be clear about one quantity, that is linear momentum. Yes, we can also say only momentum. Okay, linear momentum, it is denoted by P. What is definition of linear momentum? Momentum P of body is defined to be the product of its mass m and velocity v. Mass m and velocity v. P is equal to mv. M mass, that is scalar quantity. V velocity, vector quantity. Therefore, see, if you remember chapter 4, okay, product of scalar with vector, its resultant, its answer is also a vector. So yes, P, that is linear momentum, is vector quantity. Vector quantity means it has direction. See, this m is scalar quantity, means it may be your number. Mass means yes, it is positive number, positive real number. Yes or no? So yes, if you multiply any positive number with vector, then you know that direction remains same. So yes, direction of linear momentum is in direction of velocity. Direction of linear momentum is in direction of v. Its SI unit is, from this we can write, see, mass. What is unit of mass? Is kg. What is unit of velocity? Is meter per second. So what is unit of linear momentum? It is kg meter per second. Now, what is linear momentum? Why this quantity is required? What is importance of this linear momentum? See, if you are asked a question linear momentum for 2 marks, you have to write this definition, equation, direction and unit. Yes, for 2 marks it is only. Okay, yes, these are some examples that indicates what is importance of quantity momentum. What is importance of quantity momentum? First example, see, if there are 2 vehicles, one car and one truck. Yes, what is difference between them? Mass. Mass of truck is greater than mass of car. Okay, if I want to push them, then obviously much force, okay, is required to push the truck than the car. Yes or no? Yes, to the same speed. To the same speed. If I have car and truck at stationary condition, okay, and I want to bring them motion to a same speed, then you know that you need more force. You need more force for truck comparative to car. So see, much greater force is needed to push the truck than the car to bring them to the same speed in the same time. Okay, yes, similar one example. If truck and car, they are in motion, they are moving with same speed. They are moving with same speed. Truck is moving with 50 km per hour. Car is moving with 50 km per hour. Yes, they both are moving and I want to stop them. Then obviously much greater force is required to stop truck. Much greater force is required to stop truck than car. Why? What is difference? They both are moving with same speed. Mass. There is importance of their mass. Clear about this? Another example. If 2 stones, one light and one other heavy, are dropped from the top of building, a person on the ground will find easier to catch the light stone. See, if you have 2 objects, 2 stones, one heavy and one light, and if you drop from the same height, from the same height. Okay, what is equation of velocity? V is equal to V0 plus at. Initial velocity 0, acceleration for both of them it is g. Yes or no? So yes, their speed will be same, but mass, one is heavy and one is light. We know that it is easy to catch lighter stone. Okay, it is easy to catch lighter stone. Again, here in this case, it is importance of mass. It is importance of mass. Okay, if two objects are moving with same speed but having different mass, then we can catch easily object having light mass. For heavier particle, we need much force, much greater force. Clear about this? Okay. So yes, in these two cases, there is importance of mass. Now, third case. A bullet fired by a gun can easily pierce human tissue, but the same bullet fired with moderate speed will not cause any much damage. Yes, we know that if I have a gun and if I fire the bullet with the help of gun, okay, then it can easily pierce human tissue. Yes or no? Yes. But if I have bullet in my hand and I throw bullet like this, then it will not damage. It will not damage body. Yes. So in this case, what is importance? Mass? No. In both cases, mass is same. Importance is of speed. Importance is of speed. Okay. When bullet is fired by gun, it achieves some moderate speed, okay, and due to that speed, that mass can penetrate in body. But when we throw with the help of hand, okay, it does not achieve any speed that can penetrate inside body. Clear about this? So yes, a bullet fired by a gun can easily pierce human tissue, but the same bullet fired with moderate speed will not cause any much damage. Means from this we can say there is importance of mass as well as velocity when object is in motion. When object is in motion. Clear about this? So it is importance of linear momentum. Now, why to discuss about linear momentum? What is relation between this linear momentum and force? So see, there is relation between linear momentum, time and force. Yes, we will discuss some example and we will make some conclusion. Yes, what is relation between momentum, time and force? See, yes, you all are fan of cricket. Okay, yes, we missed IPL this time, but next time we'll enjoy it. Okay, yes, whenever fielder catches the ball, okay, if you have observed, he draws his hand in backward direction. He draws his hand in backward direction. Why? Because ball is moving with higher speed. Yes or no? It has higher speed. And if I want to stop it, means if I want to make its speed 0, means I have to change its momentum. Okay, if he draws his ball in backward direction, means he is taking longer time, then that change in momentum for longer time will cause less efforts, less force. Yes or no? Okay, the fielder have to apply less force to stop, small force to stop that ball. But if he does not draw his hand in backward direction, he has to apply greater force to stop the same ball. Clear about this? So yes, cricketer draws the ball in the hands backward in the act of catching of ball. Why? Because force does not depend on the change in momentum, but also on how fast the change is brought about. See, for example, I have one car having mass 50 kg, is moving with speed 100 meter per second. Clear about this? and I want to stop it. I want to stop it means its speed becomes 0. Its speed becomes 0. Yes or no? Yes or no? Yes. In this case, what is momentum? Yes, in this case, momentum is 5000. In this case, momentum is 0. Clear about this? Clear about this? Yes. Change in momentum. What is change in momentum? What is change in momentum? Yes, it is this 50,000. Okay, minus it is 5,000 minus 0 means it is 5,000. So yes, it is change in momentum. What I have to do? One car having mass 50 kg is moving at 100 meter per second. So its momentum is 5,000. I want to stop it. So yes, its final speed, velocity will become 0. So its momentum is 0. So what is change in momentum? 5,000. Now I can stop this car. Okay, by two cases. First, when I am applying great braking force. Okay, large braking force. Large braking force means if you want to stop vehicle, you have to apply brakes. Yes or no? If I apply brake, short brake, okay, then yes, vehicle will stop in very small time. Yes or no? In very small time. Suppose in that first case, I am taking a vehicle stops in time delta t is equal to, in time delta t is equal to, it is 20 seconds. In time delta t is 20 seconds. Yes or no? Yes or no? Yes, it is. Suppose I am taking that vehicle stops in time delta t is equal to 20 seconds. Clear about this? When I apply large force. When I apply large force. So in this case, what is change in momentum to time ratio? Delta p upon delta t. So yes, delta p upon delta t. Here it is delta p. So yes, it is 5,000 divided by, here it is 20. Yes or no? So yes, 0 cut, 0 cut. So it is 250. What is delta p upon delta t? It is 250. Clear about this? Now the same situation. Okay, I want to bring this vehicle in rest condition, but I am applying force slowly. Okay, small force. Then obviously, if you are applying brake slowly, then yes, it will take some time to stop vehicle. Yes or no? Suppose vehicle is taking delta t is equal to 100 seconds. When you apply small force. So see, in this case, what is rate of change of momentum? Delta p upon delta t. It is 5,000 divided by this 100, 0, then it is 50. Clear about this? See, in both cases, change in momentum is 5,000. In both cases, change in momentum is 5,000. But for this change in momentum, it takes different time. So yes, read this statement again. Force not only depends on change in momentum, but also on how fast. How fast means rate of time. How fast the change is brought about. Yes, in both cases, change of momentum is same, but the time is different. Here it takes 20 seconds, here it takes 100 seconds. So yes, see here what is delta p upon delta t? 250, large force. Here delta p upon delta t, 50, small force. So yes, from such experiments, from such results, we can make one conclusion. Okay, force depends on rate of change of momentum, delta p upon delta t. If delta p upon delta t is higher, force is also higher. If delta p upon delta t is smaller, force is also smaller, and it is clear from this example. So yes, this leads us towards Newton's second law of motion. Yes, what is result of last example? force is directly proportional to rate of change of momentum. If rate of change of momentum is more, force is more. If rate of change of momentum is less, force is also less. So what is statement of Newton's second law of motion? The rate of change of momentum of a body is directly proportional to applied force and takes place in the direction in which the force is acting. How to write mathematically? See, delta P upon delta T. The rate of change of momentum is equal to force. Is equal to force. Delta P upon delta T is equal to F. Yes, constant of proportionality I am taking one. So yes, delta P upon delta T is equal to F. Clear about this? Okay, F is equal to, it is delta P upon delta T. If I am taking limit delta T tends to 0, means time interval small. Time interval small. Then what happens? Then I can write this force as F is equal to, here it is, dP upon dt. F is equal to, here it is, dP upon dt. Clear about this? So yes, F is equal to delta P upon delta T. If I am taking delta T tends to 0, then time interval small, then F is equal to dP upon dt. Now we will obtain another form. See, F is equal to, I can write dP upon dt means d upon dt. What is P? Linear momentum, that is mv. And mass, that is constant. Yes, during motion velocity changes with time. Velocity changes with time, but mass does not change. So F is equal to, it is m dv upon dt. dv upon dt, differentiation of velocity with respect to time. Obviously, it is mass. Then yes, F is equal to, it is ma. F is equal to, it is ma. It is equation of force. If object of mass A is moving with acceleration A, then force acting on it F is equal to ma. Force acting on body F is equal to, it is ma. Clear about this? Okay, yes, this force is a vector quantity, because see, from this equation F is equal to delta P upon delta T times scalar quantity. Delta P vector quantity, the force is also one vector quantity. Force is vector quantity. Force is vector quantity. Force is vector quantity. Clear? And what is its direction? Yes, its direction is in direction of change in momentum, or I can say in direction of acceleration. Clear about this? Now, what is unit of this force? Unit of force. How to obtain unit of force? See, F is equal to, here it is ma. F is equal to ma. So yes, its unit of force is equal to m, that is mass. Its unit is kg. A, acceleration, it is meter per second. Clear about this? And yes, it is also called 1 Newton. It is also called 1 Newton. So what is 1 Newton? 1 Newton is equal to 1 kg meter per second square. Yes, from this we can define Newton. See, in this equation, F is equal to ma. If you are taking m is equal to 1 and a is also equal to 1, then what is value of F? 1. Simple. Again, if you are taking value of m 1, a is equal to 1, then what is value of F? 1. Yes or no? Then 1 Newton is force. 1 Newton is force to produce acceleration of 1 meter per second square on object 1 kg. On object 1 kg. So what is 1 Newton force? It is definition of 1 Newton force. It is definition of 1 Newton force. Clear about this? So yes, what is Newton's second law of motion? The rate of change of momentum of a body is directly proportional to applied force and takes place in the direction in which force is acting. F is equal to delta P upon delta T. F is equal to dP upon dt. F is equal to m. It's unit, it's unit. And what is definition of 1 Newton? Clear about this? Now, there are some points about this Newton's second law of motion, or we can say about force. If I say object is at rest condition or moving with uniform speed or uniform velocity, then you know that what is acceleration? Acceleration is equal to 0. And see from this equation, if acceleration is 0, then F is also 0. So yes, Newton's second law of motion is consistent with Newton's first law of motion. Okay, when force is 0, acceleration is 0. Clear about this? Okay. Second one. Yes, force is vector quantity. Force is vector quantity. Force is vector. Then how to write force in terms of components? Yes, I can write F is equal to, here it is, Fx plus Fy plus Fz. Then how to find this each and every component? Yes, I can find that component. Okay, components. How to find components? F is equal to, Fx is equal to. How to write Fx? See, here it is. Okay, F is equal to m dv upon dt, and F is equal to ma. So I can write x component as it is m dvx upon dt is equal to m dx. Only x component. Yes or no? How to write Fy? It is m dvy upon dt is equal to m ay. Fz is equal to, it is m dvz upon dt is equal to, it is n az. So yes, if you remember chapter number 4, position vector r0. From position vector we can write velocity vector. From velocity vector we can write acceleration vector. So similarly, from acceleration vector we can write force vector. Yes or no? So yes, components of forces. Clear about this? Okay. Now see, it is F is equal to dp upon dt, force and acceleration. It is for one particle. But for rigid body, okay, here this F means it is named external force. Here this F means it is named external force, not internal forces. Yes, we have to write the word external force. Yes, a system may have internal and external forces. To calculate this rate of change of momentum or acceleration, you have to take force that is named external force, not internal force. And yes, for rigid body, what is rigid body? Which cannot be deformed. Means distance between any two consecutive particles remains always constant. So yes, for rigid body, force or acceleration of each and every particle is same. Clear about this? If I want to open door, then I have to apply force on each and every particle? No, I have to apply force only on one particle, only on some particle. Okay, if you touch handle and if you push that handle, the door will be open or closed. So yes, in case of rigid body, to bring it in motion or to stop, we have to apply force on some particles only. Clear about this? So yes, it is all about Newton's second law of motion. Statement, equation, definition, you have to remember. Okay, yes, students, watch video regularly, make notes, and if you have any doubt, if you have any query, then please solve your query with your respective teachers. And yes, do not forget to like, comment and share our channel. Like and comment on videos of every teachers. Okay, yes, they all are doing very hard work for you. So yes, you have to watch videos regularly, write your notes, solve your doubts, and like, comment and share on videos.